So I just spent the past several years researching the end of the world, and I came away with a peculiar sense of optimism, and that is what I want to talk to you about today. So a lot of the research that I did wound up in a book that I published last year, and here's a fine picture of it, and I even have a few copies of it available. If you can spare €1 or a good conversation, I'll give you one. And one of the things that I do as a writer, I'm a science journalist, and so I like to put science into context. That's how I define my job. So I take scientific discoveries and the history of science and try to place it in a larger social context that's meaningful for my readers. Sometimes that's a very small context, and sometimes that is an enormous context. And that's certainly the case when you're talking about something like the end of the world. And it turns out that if you're thinking of the end of the world, certainly there's a lot of things that can mean. I can't tell you how many times I've been asked if I'm going to deal with the important question of the zombie apocalypse, to which I have to reply, I'm sorry, that's actually not a scientific phenomenon, so it's kind of outside my purview. But what I discovered in the course of my research, which admittedly began with a kind of science fictional question, which was, what would be the equivalent in the real world, in the world of natural history, of Godzilla attacking? What would be some kind of real world equivalent of that? And it turns out the answer is a phenomenon that's called mass extinction. And you may have heard about the idea of mass extinction before. It's often used popularly to mean a lot of different things, but it has a specific scientific definition, which is it's a moment in history when over 75% or more of all species die out. And this has happened about 5 times in the history of Earth since multicellular life evolved about 450 million years ago. So we have had these events before, and I'll explain in a minute why people are worried that we might have one again. The most recent mass extinction, and probably the most famous, is the extinction of the dinosaurs. Most of the dinosaurs were killed off about 65 million years ago when a flaming ball from space hit the planet and set off a series of events that wound up killing off about 75% of species on Earth, including, as I said, most of the dinosaurs, not all of them. And the thing about mass extinction is that the previous 4 mass extinctions, which are all just as exciting as the dinosaur one, they all begin with these kinds of cataclysmic events. One was caused, for example, by a very rapid glaciation. Suddenly, the ice caps grew enormous, then they shrank, and then they grew again, which was terrible, terrible for life on the planet. Other mass extinctions were caused by megavolcanoes, super wildfires. They are begun by these cataclysmic events, but the thing that really murders most of those species on Earth, the real killer, always turns out to be climate change and habitat change. And if you look back in the history of the planet, which is basically when I began this research project, I had to go back into deep time and look into geology. One of the things that you find when you look at these geological periods, and I happen to love this particular representation of the geological periods, is that a lot of them are divided up by extinction events. One of the ways that we divide up the periods of the Earth is by saying, there was an extinction here, so begins a new period. And there's some of these are helpfully marked on this chart. And these extinctions take about 1 million or 2 million years, which I think is useful to think about when looking at a chart like this, because it shows you just how fast that really is in geological time. It's extremely fast to have an event where basically what's happening is most life on Earth is dying. Most of the life on Earth dies out, and when that period is over, when that 1 million years or 2 million years is over, you've got an entirely new set of ecosystems. Basically, the planet is destroyed and reborn. And that's a phenomenon that became extremely interesting to me. I started out really wanting to write about death, and I became more interested in this question of how the hell does life recover from one of these events, where there's a cataclysm and then there's, sometimes millions of years of climate change, certainly hundreds of thousands of years. And so that brings me to a story that I like to tell, which is about my favorite mass extinction. Like I said, there's the dinosaur mass extinction, which I know is very popular, and there's been lots of TV shows about it, and people like it. But my favorite mass extinction is the one that took place at the end of the Permian period. Sometimes it's just called the end Permian extinction. It was about 250 million years ago. And sometimes it's just called the Great Dying. Even scientists call it that. They're not usually prone to goofy phrases like that, but the Great Dying was the worst mass extinction the planet ever saw. 95% of all multicellular life on the planet died out, and even insects died out. It was a really tough time, and it was caused by megavolcanoes, which again sound really awesome. It makes you think that there were these huge explosions. But in fact, it was actually a pretty slow process. What happened was, at this time, 250 million years ago, all of the continents on Earth were actually in one megacontinent called Pangaea. And up in the northern part, which is now Siberia, a volcano began to go off. But it wasn't explosive. It was one of those types of volcanoes where basically enormous cracks open in the Earth, and lava begins seeping out relatively slowly. But then this went on for about 1,000 years. Scientists aren't sure if it was several different pulses of lava that maybe lasted 100 years and then took 50 years off, or if it was just a continuous flow of lava for 1,000 years. But along with that lava came a ton of toxins, lots and lots of toxic gases, lots of carbon. And basically what happened was, over that 1,000 years, was the Earth had a natural equivalent of our Industrial Revolution. The atmosphere was utterly loaded with carbon, and it led to climate change, radical climate change. There was ocean acidification, the likes of which you've never seen. Coral reefs died off. Basic plant life died off. On land, almost nothing survived. The habitats were changing tremendously. Things were heating up. And in the period after the Permian, which is the early Triassic, that's sort of the time when dinosaurs first start being awesome. But at that time, the dinosaurs were relatively small. They were more like dogs. The early Triassic was struggling with the results of this climate change from this megavolcano. And you had actually some really awesome animals. I've just got a great picture here that's a Triassic scene. So there were a lot of alligator-like creatures that were mostly eating each other. And then up there on the left, you see this guy with like a weird little tail and tusks, really goofy looking. That creature is called Listersaurus, and it was the greatest survivor of the Triassic period. So there's a lot of questions about that. Why was this animal, more than any other animal really, able to get through this period of radical change in the environment while all these other species were dying out? Remember, 95% of species. Listersaurus managed to thrive. The progeny of Listersaurus speciated. They became a bunch of different creatures. They all kind of look like this, though. They look sort of like pig lizards. And they were burrowers, so they were probably eating roots and maybe the equivalent of fungus at that time. And they went everywhere. They migrated down to the south of the continent to get away from the worst of the habitat changes caused by the megavolcano. They adapted to a ton of new ecosystems. They were just incredibly adaptive animals. So the question is, if we're looking at mass extinction as an upcoming threat, which we are, What can we learn from something like Listersaurus? And right now, a lot of environmental scientists and a lot of geologists believe that we really are in the early stages of a mass extinction. And this would be our 6th. And there's a couple really basic reasons to be worried. One, of course, is we are entering a period of radical climate change. And we know from looking at these previous 5 mass extinctions that that was the real killer. There was some precipitating event, but ultimately what was really deadly was habitats were changing. And that interferes with the food supply, that interferes with animals' ability and plants' ability to thrive, because often they're used to a particular temperature, they're used to a particular type of food, and that goes away, and then they're fucked. So the question is, and also what we're seeing now, as many of you probably know, is that there are incredibly elevated levels of extinctions that we're seeing among land animals especially. So there's always some animals going extinct. That's just part of evolution. Some people die, well, some creatures die, some life forms die, also some people die, but that's not really evolution. And some speciate, so you lose a species, but you gain a couple new species. And so that's called basically just the background extinction level. You're always going to see some of that. But right now, we're seeing a real spike above that background extinction level. We're seeing elevated numbers of birds dying off, elevated numbers of amphibians dying off, and other animals too. I'm sure we could have a party and name them all and feel really, really crappy afterward. That's a danger sign. And in fact, some scientists believe that this 6th extinction started 15,000 years ago when all the megafauna in the Americas and Australia died off. You know, like the woolly mammoths and the mastodons and all the other animals that have heavy metal bands named after them. When those creatures died out, that may have been the beginning of what will be the ending for a whole bunch of ecosystems. So the question is, like I said, how do we survive a situation like that? We can only really know how to survive by looking back at previous survivors and thinking about what they did and how they made it through. So I have some good news and some bad news about that when it comes to humanity. The good news is that if you evaluate Homo sapiens just as an animal, okay? Leave aside the fact that we've invented open source software, and we have social media, and we have art, and all this bitch and stuff, and you just look at us purely as animals. We have exactly what Listersaurus had. We have big population numbers. We can adapt to almost any environment on the Earth. We're good at running away from disaster, and we can eat almost anything. That's really important. In fact, we can eat garbage and survive, as you may have noticed. So we're set as animals. The question is, because we're such, let's call us fancy animals, we have things like civilization and politics and art and science and technology, how are we going to make sure those things survive with us? How do we survive in style, in the style to which we've become accustomed? And that became a huge preoccupation for me, and it's a question that I'm still trying to answer in my work. I think, obviously, we've got the ability to adapt. So where do we look to adapt in the realm of civilization, in the realm of science and technology? My answer is that first we need to look at cities. We need to look at cities because they're one of our most amazing technological innovations. They're also quite pragmatically the place where the most people live now. The majority of Homo sapiens currently live in urban environments. And UN predictions, if you trust those, suggest that by the middle of this century, 67% of people will be living in cities. That's a huge majority. It's going to be higher in the developed world. So here in Germany, you're going to see, and even perhaps up to 75% of Homo sapiens will be living in these cities. So we got to focus on cities partly just because we want humans to survive. That's where most humans are. But also, cities are these incredible crucibles of innovation and scientific development and artistic and cultural development. They also have some bad attributes that we can talk about later, but they're a great place to focus your energy if you're thinking about how to save the world, how to save not just humans, but our ecosystems from a mass extinction. So let me take a brief detour. I've already admitted that in order to answer these questions about mass extinction, I had to go back in time into geological time. And to think about cities, I think it's useful to go back about 7,000 years in time to one of the very first cities that we know of existing. So this picture here is of Çatalhöyük. It's a Neolithic city that thrived in, 7,000 BCE. So it's quite ancient. It's the oldest city that we know of that has been excavated. So in southern Turkey at that time, around the time when people were living in Çatalhöyük, people were also developing agriculture in a very systematic way. And in fact, there's a really interesting debate that I won't get into about which came first, agriculture or the city. The answer seems to be yes. They came together. You needed them for each other. The thing that's interesting about Çatalhöyük, if you look at this picture, is that it looks very different from most cities that we have in the modern world today. First of all, people did not have streets. They entered their homes through the roofs, and so the city has the look of a bit of like a wasp's nest. It's a bunch of cells pressed together. People didn't tend to have larger houses than each other. It was sort of pre-class division in cities, as far as we know, if we just base it purely on how much acreage each person had. They had a lot of interesting early spiritual traditions that had to do with the city. They had a tradition which later was adopted in Zoroastrianism, which is when someone died, they took their body outside the city, and animals would clean the bones, and the bones would be bleached so that they weren't, stinky anymore. And then they would bury the bones of their dead in the floor of their homes. And over time, because the city was made basically of dirt bricks, they didn't have fired bricks at that time, they would build new homes on top of the dust of the old home. And so that's why these early cities are often called tells, because tell means mound. So over time, the city would actually become more and more elevated. And so not only was the new version of the city, which, by the way, this city lasted for a couple thousand years. It was really awesome. Over time, the city was built on the bones of the people who had lived there, but also on the structures that those people had built. And one of the archaeologists who works on the Çatalhöyük site, Ian Hodder, observed that it was kind of like the city was its own society materialized. There's a way in which cities are a kind of an effort at social immortality. It's a way that we preserve the shape of our society in our built structures, and we preserve the dead in that structure. And it's very intimate, but it also tells us something about how the city functions for humans, which is that it changes over time. It's a reflection of our societies, it's a reflection of our civilization, but the actual physical shapes of cities change as our needs change as a society. So what was important for the people of Çatalhöyük, the things that they cared about, aren't necessarily our problems anymore. They built this city to make, it sounds like a song, they built this city to make things easier for them on the planet so that they could have shelter all the time. They created agricultural areas so that they could have food. Their needs were being met. But today, we have very different needs. We know now that in order for us to be comfortable in our environment, we don't just need little boxes filled with bones. We also need to maintain the environment around our cities. In order for us to be comfortable in the future, we have to make sure our environment is sustained and is stable. Otherwise, we're going to change the climate, we're going to lose our food security, things are going to get ugly. So our cities need to change. They have to change. Their physical structures need to be different. So as we look to the future of the city, we have to be thinking about what do we need to do, how do we need to build them so that we can be comfortable and we can maintain our environment to keep us comfortable too. I mean, just in a really basic sense, like one thing that Homo sapiens totally loves, you may have noticed, ice caps. You know why we like ice caps? Because we like it to be kind of cooler on the planet. Ice caps are kind of a weird aberration in geological time, by the way. Usually the planet has been warmer. There haven't been ice caps. As you may know, Antarctica used to be tropical. I'm sure that was awesome. I wish I could visit. Sorry, that was 30 million years ago that it was tropical. But that gives you an idea of how recently it was that there were no ice caps. So we need to make sure those ice caps stay there. And that has to be something that we think about as we're building our cities. We have to be thinking, how do we make a city that isn't plundering the planet for energy sources that will produce more carbon and make those ice caps go away quickly? So there's really obvious solutions to that. One thing is to be thinking of cities as being metabolisms, as being part biological. So I think things like, really obvious things like, we need more wind power, we need to take advantage of naturally occurring sources of energy, we need more solar, we need carbon neutral sources of energy. This is all basic stuff. Many governments are already working on this. Even in the United States, the Department of Energy is working on this. That was what was great about the Yes Men, because they talked about how they pretended to be from the Department of Energy and were predicting this carbon neutral future. But in fact, the real life Department of Energy in the United States is investing tons of money, millions of dollars, in laboratories all over the US to develop better sources of alternative energy. And some of those sources of energy go way beyond things like just solar or doing things like recycling water. They're looking into things like, how do you re-engineer life forms, microbial life forms, for example, to be new sources of energy? So for example, people at the DOE, but also scientists who are looking at the future of energy, they're obsessed with things like algae. Because first of all, algae is really easy to engineer to do a lot of different things. It's also already a great source of energy, it's a great source of food, but with just a few genetic tweaks, algae can be turned into something that can, for example, purify water, or that can serve as an even more productive energy source. It can start producing hydrogen energy, for example. We can be using things like cyanobacteria. We can treat them, we can genetically engineer them to provide a light source. They can glow, we can add phosphorescent genes, and you could one day have in your house, you'd be basically growing mold to light your house. And one of the interesting, so a lot of the future of the city, I think, isn't just going to be changing our power sources, but actually changing fundamentally how cities are built. And that's part of what's interesting about a lot of these moves to do things like genetically engineer algae. This is a larger project within synthetic biology, which is just a new field which is about engineering biology instead of simply understanding how biology is put together. One of the projects that I think is really interesting that's come out of synthetic biology designed for cities is something called Bacillophylla. And there's two reasons why it's interesting. One, it has a great name. If you're a bio geek, you're laughing. And two, it was actually created several years ago by a group of students in Scotland. And they wanted to come up with a self-healing concrete. So there's a lot of interest now, especially among architects and designers, in materials that heal themselves because they're more sustainable. They're better in terms of environmental concerns in a lot of cases. But also, they're great for the kinds of disasters and emergencies that come up in cities. So what these students did was they took a common bacteria, they engineered it to once it was in connection with concrete, it produced a kind of epoxy. And over time, it grew to fill a crack. And what you're looking at here in this picture is just over time what happened when they cracked some concrete. They put the bacillophila into it, and over time it grew in, the epoxy grew in, and by the time that the crack was filled, the bacteria died. By the way, all of this kind of design with synthetic biology, one of the key aspects of it is engineering microorganisms that die once they've done the thing they're supposed to do, whether it's filling in concrete or healing the hull on a metal ship or sensing high levels of toxins in the environment. The point is, we don't want like runaway concrete growing on your face. I mean, I guess that would be kind of awesome, but we only want that to happen consensually, shall we say. So this particular bacteria does have a kill switch where it dies when it's done. And you can see, as a kind of beta test of this idea, how this is an incredibly evocative project, because what it suggests is that one day cities could be made of materials that we don't have to constantly be patching and replacing. You could have a city that basically looked almost like a ruin, but it would be alive. It would be, covered in scars because cracks had healed themselves. It would be covered in algae that was being used for water filtration or runoff. Maybe the inside of your house would be full of algae that you were growing for energy, algae that you were using for lights. Life would be a little bit dirtier, but it would be sustainable. The city would not be in contradiction with the environment around it. And I think over time, you might get cities that were essentially, they were carbon neutral, they were recycling water, they were basically functioning as part of the environment around them. But of course, they would also have like really awesome high-speed internet and all the technologies that we like to have, but they would look more like something out of science fiction. They might look like trees, they might look like mountains. But of course, and eventually, of course, even our engineering capabilities could reach into things like shepherding the atmosphere itself. Not just caring for the city and the environment around it and making sure that we're not stomping on animals' migration patterns, but actually intervening in the carbon cycle, which is what governs these periods of ice house and greenhouse that are so important to our lives and so important to our habitats. So at some point, we really may be intervening in the way our atmosphere functions so that we can keep those ice caps that we like so much and which the planet doesn't give a shit about, because on a cyclical basis, the planet gets rid of those ice caps because it's designed to do that. It's a huge carbon cycle, it's a chemical computer. So what I'm saying here, I like to characterize as pragmatic optimism, because although it sounds like I'm incredibly excited about like, wow, we're gonna have this amazing future where we build fantastic cities, the fact is that A, this is based on technologies that we have in the lab today, which could be deployed very soon. So that's one element of pragmatism. But the other part of that is, we don't know for sure that this will happen. This is a vision to strive for. This is something that we could work toward. But of course, there's always the possibility that we won't do that, and that our future will look something like, living in a cave and eating bugs, which we might be eating bugs anyway because it turns out they're a really great source of energy, blah, blah, blah. But nobody really wants to have that kind of living underground, being cannibals because we've destroyed the environment, maybe we've irradiated it. There really are multiple pathways to human survival. And I guess, as I said earlier, the good news and the bad news is that we're gonna survive either way. Either we're gonna survive in our biological cities that live in harmony with the environment, or we're gonna survive in some terrible, impoverished, famine-ridden, pandemic-riddled way. But let's say, just for fun, just to be happy, that we make it this far. We build cities that don't destroy the environment anymore. We manage to do enough environmental remediation that the climate changes that occur are something that we can survive in relative comfort. So we head off a mass extinction. Well, the fact is that the planet is still fucking dangerous. Even if we're totally good citizens, totally carbon neutral, we're still running into the fact that flaming rocks from space can actually hit the planet and destroy us. Mega volcanoes are probably not something that we're going to be able to stop, even if we have wind energy. So planetary life is going to continue to menace our future. So ultimately, as we get further into the future, hundreds of years, thousands of years into the future, our goal for survival has to be to start building these awesome cities off-world. I don't care where. We can build them in giant halo worlds. Maybe we can build them on uninhabited rocks somewhere. The point is, hopefully no one's living there, please. The point is that we need to, in order to survive, we need to scatter further from this world. And one of the things that I often find entertaining about talking to people about this is, like, we've all grown up with, well, many of us have grown up with things like Star Trek and Star Wars, and it's all basically white people in spaceships with human form, right? Like, we're gonna make it into space, but we're gonna look exactly the same, and we're gonna use rocket fuel or warp drive, which it turns out, by the way, warp drive is like polluting subspace or something like that. I don't know, maybe you guys saw that episode too. But anyway, it's polluting. And rocket fuel is really polluting. If we get to space, we are not going to use rockets. What we're going to do is we're going to have to build technologies, perhaps unlike anything we've seen before, something like this space elevator here, which was actually an idea that was thought about pretty seriously by the American Space Agency, NASA, in the 90s, and has also been contemplated even by Google, which of course, Google, right? They have like a robot army now. So they're thinking of everything. And I think they briefly entertained the idea of building a space elevator. But a space elevator is basically a sustainable way of getting people and objects off the planet. You use a thin tether, which is stretched about 100 kilometers. And on the end of that tether, so it's stretched 100,000 kilometers from the planet. And at the end, you have a counterweight. And actually, here in this picture, what you're seeing is you're sort of in the counterweight up here, which is like a space station. And you can see down the tether, there's a little space elevator coming up, which of course is not going to be little. It's going to hold a lot. And the idea is that if you could build a device like this, you could be bringing people up that elevator constantly. There's many different ideas of how it would be fueled. Some of them completely crackpot, some of them only mildly crackpot. A lot of them involve lasers. But the idea is that it would be a carbon neutral way of getting out of the gravity well, which is a really hard problem. How do you do that in a carbon neutral fashion? But the point is that the future of our species may look a lot different than you think. And if there's anything that we've learned from the history of mass extinctions and the history of surviving mass extinctions, it's that one thing is absolutely certain. Regardless of whether we go to space, regardless of how we build our cities, we are going to evolve. In, 800,000 years or so, if we're still around, we're not going to be Homo sapiens anymore. The average lifespan of a mammalian species is about 1 million years. And usually after that point, they speciate. They go extinct sometimes too, but they turn into other species. We evolved from another species, from Homo erectus, who was totally a badass. Homo erectus invented fire, so thanks to Homo erectus for all that. So that means that when humans evolved, when Homo sapiens evolved, we actually already had one of the awesomest tools ever. We had fire. And our progeny, if they go to space or stay here in biological cities, will not be like us anymore. They won't be human. If we go to space, we're going to have to engineer ourselves to be radiation resistant. We may have to change ourselves to exist in other environments. We may adapt to other environments. So the future is going to look really weird, no matter how we survive. It's not going to look like a bunch of white dudes in a spaceship. And that's fantastic. That's a guarantee from nature and evolution that we are going to be something different when we survive. And that's really what we have to look forward to, is that constant change. And the hope is always that we can help that change go in a direction that maintains the planet in a way that, as I said, keeps us in the lifestyle to which we've become accustomed, with lots of scientific innovation and fantastic art, or it might take us in a dark and terrible direction. And it's really up to us right now to make that decision. So thanks very much. And I think we can have questions somewhere. There's like a microphone somewhere. But thanks a lot.
Hi, my name is Joseph. I'm here from California, and I was wondering, do you think human beings' over-exercised amygdala plays a negative role in how we perceive the future? Do you think that makes human beings a little bit more pessimistic in how we approach societies of the future?
I'm sorry, I missed the one part about what is it that makes us more pessimistic? Did you say the amygdala?
Yeah, the amygdala organ of your brain
yeah.
that helps you perceive danger.
Yeah.
Do you think that plays a negative role in how we foster new technologies and how we assume our ability to advance as a society?
That's an interesting question. I mean, there's been a number of studies in neuroscience that show that humans tend to remember negative experiences better than positive experiences. If you've ever been part of an internet community, you know exactly what I'm talking about. We always remember the nasty emails better than the friendly ones. And there's a good evolutionary reason for that, which is like, don't make the same mistake again. And I think that in some ways, having that capacity can be very good for us. The problem is that we also tend to forget those negative experiences at a species level. So we remember the personal negative experiences, those things that stick in our brain, like, oh my God, that guy called me a flake like 15 years ago. But it's really hard for us to remember something like, oh my God, we colonized the Americas 500 years ago and it killed a bunch of people and that was terrible, we never want to do that again. Let's go colonize a planet and oppress those people on that planet. Sorry, that's just a sort of fantasy of how we might reenact a terrible crime in history. And so I think, in a sense, what we need to do is develop that memory for negative experiences in a more civilizational way. And even maybe extend it to things like remembering what happened in the previous mass extinction, which is there was climate change and that really destroyed life on the planet. If we could, as a civilization, be thinking about that and keeping that in mind, I think it would make it easier for us to make decisions now to build better cities and to build better technologies. And I don't know how to do that. I've actually read papers where people suggest things like taking drugs or modifying humans to be more empathetic, to be better able to remember these kinds of things. Yeah. And, you know, that may be one way that we will modify ourselves. We may have to modify ourselves to be more collaborative or more socially aware. It sounds creepy, but so do a lot of these possible futures. So yeah, I don't think it's so much remembering negative stuff that causes us problems. In a weird way, I think it's forgetting it is what really causes the problem.
More questions?
Hi, I wonder how the next coming mass extinction will be different. So next to having natural catastrophes, we have this nuclear power plants everywhere, and if there's a disaster, it changes everything on the planet, like even if just one power plant explodes. So is it that all the surviving species will like turn into, I don't know, freaky mutants?
Giant tarantulas. No. You know, we actually have had potentially several radiation disasters before on the planet. And in fact, the Ind-Ordovician mass extinction, there is a theory which is, I mean, there's a lot of theories about it. So there's one theory which is, you know, heavily disputed, so take it with a grain of salt. But there's one theory that those ice ages that I described were brought on by a nearby supernova which bombarded the planet with cosmic radiation, which would have actually ionized particles in the stratosphere and caused there to be a very reflective cloud layer, which would have brought on a very quick cold snap, which would have resulted in this rapid glaciation and everything in the oceans getting fucked. It was all ocean life at that time, so glaciation was a really bad deal. So I think that what would happen with a radiation disaster wouldn't necessarily be all that much different from, say, a mega volcano disaster or any other kind of disaster that radically transforms habitats, because that's the real disaster, right? There's some precipitating event, whether it's radiation, whether it's enormous wildfires, but then over time, you've got that million years of die-offs. That's because habitats have changed. And so, of course, when you have a nuclear disaster now, it does result in cancers and mutations, deadly mutations. Unfortunately, it doesn't create like giant rats and super spiders, which would be awesome and cool. It doesn't create Godzilla yet, as far as I know. It actually just causes death. And it causes localized famines because, of course, it's killing off food sources and things like that. So in a way, every mass extinction starts out in its own unique way, but it always ends up looking like starvation. Always ends up looking like food sources are going away, habitats are going away, species are dying. And you know, when a species dies, somebody eats that species, pretty much always. Well, I'm sure we could name some species that don't get eaten, but I'm hard-pressed to. I actually am hard-pressed to. People always bring up wasps. Like, what the fuck are wasps good for? But there's other insects that eat wasps, and wasps turn out to play a really good role in the ecosystem. So I think, yeah, they all, like I said, they all wind up with this kind of horrible outcome of just everyone starving.
So I'm from Montana, all the way over there, and Native American. I grew up eating native food that didn't require fertilizer and all that. How do you see our food systems in the future? Like, is it going to be sort of green here on out, or?
It's a really good question. I mean, I think one of the most pressing issues facing us is food security. And part of the issue there is food availability. And part of it is looking at agricultural techniques. And so when you're thinking about things like cities and changing the way we live in cities, and I didn't go into this, but a huge part of that also involves changing the way we think about agriculture, changing the way we think about land use, because agriculture is ultimately land use. And a huge amount of our current problems around habitat change, including stuff like ocean acidification, come from things like enormous factory farms where you have tons of agricultural runoff that's going into the ocean or going to other water supplies in landlocked areas and poisoning them and acidifying them. So I think that one way to frame survival for Homo sapiens is to appeal to people's desire to have food security. One of the things I've found, and many of us have found in talking about issues around climate change and habitat change is, well, at least in the United States, there's a lot of pushback on that. There's a lot of people who just don't believe that there's such a thing as climate change. But everyone believes in wanting to have food and understands the idea that if food starts running out, it's going to be a very bad situation. So I think that that's a huge part of reforming cities, basically. And yeah, big part of it is reforming farming techniques. So I look forward to that. Do we have time for another question, or I don't know.
I was interested by your take on infrastructural change, but as a species, we've been able to establish infrastructure incredibly fast, and I feel like that will have to change as we have more and more people. Do you see seasteading, or cities or societies at sea, as a plausible future for human beings, considering that most of the Earth is actually surface water? What's your take?
I think that would be awesome. My feeling about how we need to be dealing with the growing Homo sapiens population is that we do need to concentrate people in cities for all kinds of reasons. There's economic reasons. Economies of scale allow you to provide better health care and better food for people if they're grouped together. It allows for better waste management and recycling. If you could create a city at sea that was part of its local environment, so it was carbon neutral, it wasn't polluting the waters around it, I say why not? Because it's, as long as you have that economy of scale, there's plenty of ways that you can do farming in the ocean, but there's also a lot of very delicate ecosystems in the ocean as well. And so, for example, around coral reefs, as we've seen recently in the last 20 years, ocean acidification is really destroying this basic part of the food chain, the coral reefs. So you have to be careful about where you build your seastead. It can't just be on top of an old oil rig necessarily, although that's very charming. It has to be something that is pretty futuristic, not like anything we have now. But I would love to see that. I mean, why not, as long as it's functional. So go seasteading. Socialist seasteading. One day that will happen.
Hello.
Hello.
I'm Michael. I have a question about the information dimension of such a mass extinction. So, do you believe such concepts like the foundation of the long now, they are really important because we can survive as an animal, but a lot of information would be lost?
So are you asking whether we would lose a bunch of information during a mass extinction? Well, as I was describing mass extinctions, one of the things I noted was that they take a while. So the question is, what kind of mass extinction? Is it happening over a period of 100,000 years or 200 or 300? These things take time. So it's not necessarily going to be an asteroid hitting the planet and like taking out a huge amount of information. But it is a good question. I mean, we obviously have to be thinking about redundant data storage. And we have to be thinking about storing data that isn't just Wikipedia. We have to be thinking about storing genetic data, things like many different nations have seed vaults. I think the most famous one is off the coast of Norway in a cave where they have a lot of seeds that preserve the genetic diversity of crop plants. Those are the kinds of things that I think we really need to be thinking about, is that kind of data, the diversity of species data. But I'm a little bit less worried about a scenario where, for example, the internet goes down and we lose every piece of information on the internet. It could happen. And I hope we do have redundant backups, in Faraday cages deep beneath the sea or wherever the hell they are. But I think what we're really talking about is much more an issue around data that's needed to improve access to food and improve our ability to get carbon neutral fuel. So that's the kind of data that I'm most concerned about, environmental data.
We have time for one more.
Yeah, one more.
So much food for thought.
All right.
Okay.
All right, thanks very much, you guys.